Welcome to Electronics Techie. So in this video we discuss about the Verilog code of full adder. So the full adder circuit diagram, it's look like this, the logic diagram. So here whatever the full adder is, there is a sum and the carry, we all know about this. So first of all, for full adder, how many inputs are there? There are the 3 inputs. What are those? A, B and the C. So how many outputs we get? So sum and the carry, we get sum and the carry. So if full adder is nothing but our addition operation, means in half adder we can give only 2 inputs only, means 0 and 1, 1 0 like that. So whenever we go into the real time, but if it may be generation of carry also. For suppose if the inputs are like this, so here we can easily use a half adder, but here we can easily use half adder, then the sum is 0 and the carry is 1. But here there is a 3 inputs, so how half adder will work? So for this purpose, so we have to move on to the full adder. So here full adder, there are the 3 inputs. So that's why by using this full adder we can also add the 3-bit operation also. In half adder we can just add 2 bits only, but in full adder we can add 3 bits. So that's why I use full adder. So I think why you move to half adder to full adder is clear. So now how many inputs we observe? A, B, C. So if any carry is generated, then we can simply add like this. So how many outputs? Sum and the carry are the outputs we observe here. So for 3 variables, so 2 power 3 is nothing but 8, we get 8 combinations. So nothing but 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So like that we get combination. So sum is like nothing but, so for sum the formula is A XOR B XOR C. So for carry the formula is AB, means A AND operator with B, and BC plus CA. I written already here. So C. So this is the formula for sum, this is the formula for carry. So you can substitute these ABC values in these two equations, we get sum and carry. So for your simplification, I just simply use one first thing. So 0 XOR 0 XOR 0. So 0 XOR 0 is nothing but 0. Again 0 XOR 0 is nothing but 0. So sum is 0 and the carry. So 0 0 plus 0 and operator with 0 plus 0 and operator with 0. So finally we get 0. So carry is equal to 0. Like that we can substitute every combination in this formula. So you simply get the sum and carry. So how you get truth table? If you have any doubts, you can comment it. So this is our full adder block diagram, means XOR operation is nothing but we simply use 3 input XOR gate. So for AND operations, there are the AND operations here, so that's why you use 3 AND gates here. AND gate 1, AND gate 2 and AND gate 3. So finally our results of all AND gates will give into the OR gate, that is addition operation. So here it is XOR gate. Like that it is our block diagram. So it is our sum formula and it is our carry formula. Just remember these two formulas. By using these two formulas we are designing the full adder code. So now going to the full adder code is design code is like this. So double slash is nothing but it represents the comments. So it is our design code here. So first we have to, in Verilog, every time I say that we start with module and end with end module. So module is nothing but we simply write start with module keyword and then is a module name. So you can give any name, but here the code is related to full adder, that's why I simply use full underscore added. Doesn't we can't give full space added, there is no space. If you give space means it will be wrong. So use underscore, don't use any special characters or starting with any numbers like this. So you simply give full underscore added. So what are the inputs we observe here? A, B, C are the inputs. So that's why I simply give input A, B, C. Means input is nothing but it is our input port. Outputs are sum and carry. So our output ports is nothing but sum and carry. So what you have to do now? So here there is a sum formula and carry formula. We know the gate symbol. XOR operation means it is cap, and AND operation means ampersand, and OR operation means a single line like that. So now we know the formula A XOR B XOR C. So we can, what we have to do, we have in data flow modeling we simply use assign keyword. So by using assign keyword we can assign the values of RHS side to LHS side. So the formula, sum formula is nothing but A XOR B XOR C. So that's why you write A XOR symbol in Verilog is represented as cap. So cap B and the XOR again, so cap C. So like that we can write the symbol, and then again carry formula is AB plus BC plus CA. So now simply observe AB. So A into B, this symbol is our OR gate. So whatever we write, the dot A B is nothing but it is our AND gate. So that's why represented with A ampersand B, and it is OR gate. So plus is nothing but our OR gate. So we simply write a single line. and the B and C, OR operation C and C. So now understand by using this AB means A and operated with B. This dot is in Verilog, you can represent it with ampersand. So plus. So plus is here represented with a line. Like that we can complete this formula, and this value is assigned to carry by using this assign keyword. So then we can end this module with end module. So it is our design code. Up to now, if you have any doubts, you can comment it. So next we move into the test bench code. So test bench code is mostly similar to everything. So just we have to remember the syntax, what you have to done next, what you have to write next. Like that we can simply write everything. So now what you have to do is you simply write module name and the full underscore adder underscore TB. You can write any module name here. So it's up to your choice. And the whatever the inputs is written here, ABC, that can be written in reg data type, and whereas outputs will be written in the white data type. Why we use reg in every video I say that, but why I particularly mention every time in some of few want about full adder only, so doesn't watch other videos. So maybe they can lose this point, that's why I mention everywhere. So reg means whatever the variables we used in the initial block, it must be reg data type only. So that's why we use reg only. So otherwise input ports are maybe reg or netted data type, but because of initial block, the variables which are present in the initial block, it should be reg data type only. So that's why you particularly mention it is a reg. Without initial block, we can simply represent it with wire also input ports. So why use inputs are reg and outputs are wire means this is the reason. So outputs are must be wire only, because we have to assign different values for different changes in the inputs. So whereas reg means because of initial block, it only consider the reg data type. So that's why simply mention the reg of input ports. What are the input ports here? So now it is our instantiation here. So whatever the design code name, design code module name, full underscore adder, we can simply instance here, and Teju is our instance name. Why I can write instance in mostly we will log DUT and UUT use design under test like that. So why I mention Teju means because you can not, it is not a particular for DUT and UUT, you can use any name. So it is up to your choice. But why you particularly mention means it is some specific rules like that, means you have to meaning, we have to give some meaning why you write like this means. So that's why you can mention why I write means for your just clarification. Not only you can DUT, you can use anything, that's why specify my name. So use DUT for most your preferences when it is like professionality. So why I mention means you just know you can use any name like that. So that's why I can simply mention that it is not a rule you must and should use DUT and UUT like that. So for that clarification I just mention my name. So okay, then we can connect ports here. So port connections, every time I say port connections are two types, and name and the order. So by name and the order. So here I can connect by name. So by order means you can simply write A comma B comma sum comma and the carry. If you have more variables, then you can use name, because there is no clumsiness when you are assigning. So here I connect the port connections. So initial begin, now we have to give the input values to what you can do in the initial block means whatever the inputs we consider. So you can give different combinations in the initial block. So there are multiple statements, that's why you start with begin. So again I can give different combinations 0 0 0, and after 5 seconds delay. So /5 is nothing but our delay. So again I give 101 combination, and again I give 5 nanoseconds or 5 time units of delay. So then again 010 another combination I give, and after some 5 nanoseconds I want to stop our simulation. So $finish is used to stop the simulation for particular time period when you want. So then this begin is stop with this end keyword. So then again initial begin and end means, so why you write this display means whenever you want to know the particular values and the truth table like this, so it can be displayed in the yesterday previous video I say that in bottom of the code we can some values like this. So for that purpose we can use this display statement. So whatever you can display here, it will be display on your bottom of your code in EDA playground. I am saying about EDA playground because I explain these codes in EDA playground, that's why I simply mention. If you use any other tools means there is some certain block which is display something, how to particular block for the displaying something what you want. So otherwise there are some statements according to the coding and execution purpose like that. So you can use for your display statement for your better understanding, otherwise you can simply ignore and initial begin. So now every time I say that these 4 lines what you have write is for waveforms. So for EDA playground we have to use these 4 lines for to get the waveform. So then we can simply end with end module. It is our test bench code. Till now if you have any doubts you can comment it. So after the simulation we simply run. So then you get this waveform. So how you get this waveform? by whatever the inputs or whatever the different combinations we are given in the initial block, that will be executed here. So here we can double tap on this scale and then you get this line. So whatever the line you can double tap here, then the line will be changes from this scale when at which point you want the values. So then click here at that point and then we get the values here. So for 0 0 1, a is equal to 1 and the b is equal to 0 and c is equal to 1. So now cross check whether your code is correct or not. So what is our sum formula, x or b x or c? So is nothing but 1 XOR 0 XOR 1. So 1 we have to know the truth table of XOR gate. So 1 XOR 0 is nothing but our value is 1. So again 1 XOR 1 is nothing but our 0. So our sum value is sum value is nothing but 0. So now check sum value is 0. Okay, it's correct. Next carry. So carry formula is nothing but AB plus BC plus CA. So A value is 0, A value is 1, B value is equal to 0 plus B value is equal to 0, C value is 1 plus 1 into 1. So its value is 0, 0 plus this value is 0 plus 1. So finally our carry is 1. So cross check whether carry is 1 or not. So whatever the truth table, whatever the different combinations, the output will be equal according to our truth table and our formulas. So hence whatever we done, the code will be correct. So like that we can cross check whether we can done correct or not. If you have get any errors in your code, don't worry about that. You can if you try to solve those problems, and you can use ChatGPT and any online means there is a ChatGPT like that. So you can use any online website like that. So you can solve your doubts. So then also you don't get any any solution for that. You can simply comment, I get this type of error like that. So what can I do like that? You can comment it. I definitely give the suggestion if I know. If I don't know also, I try to find that and then I give to you. Until then, thanks for watching. Up to now it is our full adder design code. And if you have any doubts, you can comment it. And until then, bye.